Good morning. Welcome to Dear Channel, Dear Teacher Channel. Second day of circles. Maybe today will be the last day for the circles. And I have completed the conceptual part and also the first exercise. Okay, first exercise I have completed. Now I am going to do second exercise. So I told you, as I already told you, that this chapter is very easy, and we have very less number of problems. Okay, now 10.2. 10.2. Okay, question number 1 to 3. Choose the correct answer. Choose the correct answer. From the point Q, the length of the tangent is 24 and the distance of P is equal to, like, and so on. So let me take a circle. This is a circle. Center O. Maybe my center is not exactly in the middle. From the point Q, the length of the tangent. Okay, diagram is not given, so we have to find out whether Q is on the circle or not. Okay, if you read it carefully, you will come to know. You can easily draw the figure. Okay, the length of the tangent to the circle is, so let me assume Q is outside. The length of the tangent, say this is the tangent, is 24. Okay, and from the center 25. Q is from the center 25 centimeters. So find the radius. Radius is equal to, this radius is equal to question mark. Very simple and conceptual question based on the basic concept. So now let me say this is A and this is O. So QA is the tangent, which is equal to 24 centimeters, and OP is equal to 25, and we have to find out OA. So triangle OAQ is equal to right triangle, because OA is always perpendicular to the tangent. So you apply Pythagoras theorem there. Hypotenuse in this triangle is 90 degrees is here. OQ is the hypotenuse. So OQ square is equal to OA square plus QA square. OQ is 25 square. OA is, we don't know. We have to find out this. QA is a 24 square. Therefore, QA square is equal to 25 square minus 24 square. So 625 minus 576. 1549. So QA is equal to square root of 49, 7 centimeters. So the radius of the circle is 7 centimeters. A is the correct answer. A is a correct answer. So for all the problems, you just go through the problem, read the problem 1 or 2 times, and then start putting the diagram, drawing the diagram, okay, in symbolic way. then you will come to know where what concept you have to apply. So just by reading you won't be getting idea. तुमको आइडिया चाहिए तो डायग्राम ड्रा करेंगे तो आइडिया आने के लिए चांसेस है 90% चांसेस है. सो प्रॉब्लम देख के डरो मत. यू स्टार्ट रीडिंग and try to draw the diagram. Okay, so now let me go to another question. He has given the diagram. He has given the diagram and 10.11 and let me draw the diagram. Okay, and center. It is there are T is here, this is a point, this is one tangent, this is one tangent, T, P and Q. Okay, this angle is how much? 110 degrees. We know that radius is always perpendicular to tangent. Because it is a multiple choice question, you don't need to do any answer. You can write directly the choice, right? But let us understand. So now PTQ is how much? This is PTQ. This is how much? Now we know three angles. This is O. POQT is a quadrilateral. Now angles, known angles are 110, 90, 90. So angle PTQ is equal to 360 minus these three angles. Some angle, some property, sum of four angles in a quadrilateral is 360 degrees. This angle is given, these two are 90, 90, very simple. So 360 minus 200, 290. So 0, 16 minus 70, that's it. 70 degrees is the answer. B is the option. Option B is correct. Okay, so let us go to the next question, third question, exercise 10.2, third question. Tangents PA and PB from the point. Diagram is not given. Read the question and draw the diagram. Okay, so again I am drawing a circle. For me it is very easy. For you, you have to have some arrangement to draw the circle. PA, PB. P is an outsider, exterior point. So PA is this is PA, this is PB, inclined to each other at 80 degrees. And find angle POA. It is like previous problem only, but POA he asked. This is question mark. So in the previous question, other thing is given. Now it is. So now we have already proved these two triangles are congruent. Am I right? In the theorem, we have proved OAP triangle OAP is congruent to triangle OBP by RHS. We have already proved in the theorem. So in that cases what happens? By CPCT, these two angles are equal. Angle OPA is equal to angle OPB by CPCT. Okay, So that therefore angle OPA is equal to angle OPB is equal to 80 by 2, so 40 degrees. So each one is 40 degrees. Right? Now you take in triangle OAP. So 40 degrees plus 90 degrees plus angle POA. అంటే ఈ మూడు యాంగిల్స్ అన్నమాట 1 2 3 మూడు యాంగిల్స్ ఈజ్ ఈక్వల్ టు 180 degrees. సో దేర్ ఫోర్ యాంగిల్ POA ఈజ్ ఈక్వల్ టు 180 minus 130 which is equal to 50 degrees. So angle POA is equal to 50 degrees. A is the correct option. A is the correct option. So this is what is Ved Sharma. Yeah, I'll try because in my for me I am getting a good sound. Anyhow, I'll try to change the cells in my microphone so it will give you a good voice. See, you can hear my voice. For me, I am getting a good sound. So I'll try to change my cells in my microphone. So for today, please bear with my low sound. Now 3 questions are over. Let us go to the 4th question. Okay. 4th question. Prove that the tangents drawn at the end of the diameter are parallel. End of the diameter. This is at O. So 4th question, question number 4. Prove that the tangents drawn at the ends of the diameter of a circle are parallel. You draw one diameter. AB is the diameter, and draw one tangent here, one tangent here. So this is L and this is M. Now you have to prove L is parallel to M. AB is a diameter, L, M are tangents. So now to prove L is parallel to M. To prove any two lines parallel, you have to take either corresponding angles equal, or alternate interior angles are equal, और कोई इंटीरियर एंगल्स आर सप्लीमेंट्री. ये तीनों में से एक पॉइंट लेके हम पैरेलल प्रूव करना है. इफ यू वांट टू प्रूव एनी टू लाइंस पैरेलल, either alternate this is AB will become a transversal and these two are alternate interior angles. So this is already 90 degrees, this is 90 degrees. So angle OA, let us say P. OAP is equal to 90 degrees because radius is perpendicular to tangent. In the same way, let us say OBQ is also equal to 90 degrees because M is perpendicular to radius. So that implies alternate interior angles are equal, therefore L is parallel to M. Say this sum is looking very simple, but sometimes we don't know how to write the steps. This is how you have to write the step. Okay, so a simple question, you may be getting this question for 1 mark or 2 marks also. Okay, 2 marks question. So you can prove even co-interior angles also supplementary, even if you take these two, 90 and 90 also 180 degrees. So this is one more way, right? Our target is only to prove L is parallel to M. Either you take alternate interangles or co-interangles or corresponding angles. So now let us go to question number 5. Prove that the perpendicular at the point of contact, prove that the perpendicular at the point of contact to the tangent to a circle passes through the center. So let us have one more O. So perpendicular at the point of contact, that means you have to draw a tangent first. Okay, PQ is the tangent, PAQ is the tangent, A is a point of contact. Now draw radius. So what we have to do, the radius, the perpendicular at A, let us draw. AB is perpendicular to PQ. You can have simply OA also. So this AB passes through the center. This is what we have to prove. Okay. So this B can be interior, can be outside, can be on the circle also. Anything. So our target is AB is already perpendicular. Okay. This entire thing is given, and RTP AB passes through center. This is what we have to prove it. Okay. So now how to prove? Suppose if it doesn't passes through center, okay, you have to take the indirect proof. If it doesn't passes through the center, what happened? There will be one more line. Let us say this is AB, okay, and when AB dash is the passing through the center, right? So that means OA is a radius. If AB is passing through O, AB dash is passing through O, OA is radius. Radius is perpendicular to tangent. So, but here AB is perpendicular to tangent. So our assumption is, that means AB dash does not passes through the center. It AB is passing through the center. So it's an indirect proof we have to apply. Okay. So now you understood the indirect proof. All right. Next question. The length of question number 6. Tanbir Ahmad, Veer Sharma, all of you, good morning. Question number 6. Question number 6, 10.2 is the exercise. The length of the tangent from A at a distance 5 centimeters from the center of the circle is 4 centimeters. So again here you have to take a circle. This is the circle. Take the center O. Okay. I told you, read the question as many times as possible till you understand, so that you can draw the problem easily. So tangent of the length from a point A at a distance 5 centimeters from the centimeter. So this is A is here, right, from A, and this is the tangent AB, and the radius is this one. Radius is length of the tangent from a point A at a distance 5 centimeters from the center, 5 centimeters, OA is 5 centimeters, and the length of the tangent is 4 centimeters. Okay. Find the radius. It is like in the multiple choice questions. Okay. So OB is perpendicular to AB. AB is the tangent. AB is a tangent, and which is equal to 4 centimeters. Okay. Therefore, triangle OBA is right triangle. Therefore, Pythagoras theorem. Because we know two sides, we have to find out the third side. రెండు సైడ్లు వచ్చి మూడో సైడ్ ఫైండ్ అవుట్ చేయాలంటే పైథాగరస్ థియరం. ఓకే. OB square, this is 90 degrees, OA is the hypotenuse, OB square plus AB square is equal to OA square. OB we have to find out, AB is 4 centimeters and this is 5 square. So OB square is equal to square root of 25 minus 16, 9, and OB is equal to 3 centimeters. So therefore radius is equal to 3 centimeters. Okay. This is also a 2 marks question, a very common and basic problem. Okay. So now let us go to one more question, 7th question. Okay. 7th question. So here two concentric circles are given. So what are concentric circles? Circles with the same center. Okay. So circles with the same center. These are the concentric circles. Okay. For both the circle, center is same. Concentric circles, the circles with having the same center. So now these two are concentric circles, and radiuses are given. Bigger radius is 5 and smaller radius is 3. Okay. Let me write smaller radius is here. How much? 3, and bigger radius is 5. Okay. And find the length of the chord of the larger circle which touches the smaller circle. Say this is the chord, AB is the chord of the bigger circle which touches the smaller circle at P. So AB is a chord of bigger circle which is also equal to tangent at P. Okay. So then find the radius. Find the radius. No, I'm sorry. Find the length of the chord. You have to find out AB. So we just know both the radiuses. Okay. So now let me join OA. OA, you join it. Okay. So now this is 90 degrees because OP is perpendicular to AB, radius is perpendicular to the tangent, and this different color is 5, radius, bigger radius, and OPB in triangle OPA is a right triangle. AP is equal to square root of OA square minus OP square, Pythagoras theorem. So how much? 25 minus 9, 16, which is equal to 4 centimeters. AP is equal to 4 centimeters. OP is perpendicular to AB and also OP bisects AB. That means AP is equal to BP is equal to 2AB. Sorry, half AB. AB by half. So AP we got already 4, AB by 2, cross multiply, AB is equal to 8 centimeters. So the length of the card of this one is 8 centimeters. Okay. So this is how question number 7 are to be done. So I hope for today till these things are okay. In my next class I will complete the rest of the problems. I hope you understood. Okay. See you in my next class. Like, subscribe and share. Thank you. Bye bye.